Welcome to Future Doctor NEET Academy for the problem solving session in NEET Physics. Topic chosen today is from Chapter 7, Alternating Current, shortly AC. Let's move to first question. The variation of EMF with time for 4 types of generators are shown in the figures. Which among them can be called AC? Option A, B, C, D. Here are all the things for alternating current. Alternating current or alternating EMF, that is magnitude as well as direction changes periodically or reverses periodically. That is both in positive and negative direction. Here A, B, C, D, all the figures are comes under AC only. So option D is the correct answer. Let's move to question number 2. A circuit when connected to an AC source of 12 volt gives a current of 0.2 ampere. The same circuit when connected to a DC source of 12 volt gives a current of 0.4 ampere. The circuit is dash. That is, for DC, if you use capacitor C, it blocks. That is, it acts as an open circuit. It means no current flows in through C. Okay. So in a circuit, capacitance cannot be used. Therefore, series LR, L is an inductor and R is a resistance only can be used. If you include a capacitor, then it will not work for DC. So option A is the correct answer. Let's move to question number 3. A small signal voltage V of t equal to V naught sin omega t is applied across an ideal capacitor C. Then dash. That is power formula. Power P equal to V I cos theta. Here cos theta is a power factor. And theta is a phase difference. Phase difference between the voltage, that is EMF, and current for capacitor is pi by 2. Theta equal to pi by 2. Then cos 90, that is only pi by 2. Cos 90 is 0. So power P equal to 0. That is over a full cycle, capacitor C does not consume any energy from the voltage source. E is 0 and P power also 0. Option A is the correct. Let's move to question number 4. A 100 ohm resistance and a capacitor of 100 ohm reactance are connected in series across a 220 voltage source. When the capacitor is 50% charged, peak value of the displacement current is dash. Formula is Z equal to square root of R square plus XC square. And R is given 100 and XC also 100. So 100 square plus 100 square root. That is 200 square. That is 100 into root 2. 100 into root 2 volts. This is your impedance Z value. And you want to find the displacement current. Displacement current I naught equal to V naught by Z. And V naught is given 220. So 220. And then this is by Z. Z is 100. No. What's the value of Z? 100 root 2. 100 root 2. And V naught is 220 root 2. Then it gives 2.2 volts. 2.2 ampere. That is option A. Option A is the correct answer. Let's move to question number 5. A coil of self-inductance L is connected in series with a bulb B and an AC source. Brightness of the bulb decreases when iron rod is inserted in the coil. That is the correct answer. That is, when iron rod is inserted means it's having inductance. And relation between inductance and current is I is proportional to 1 by L. So inductance of a coil increases. When inductance increases, I value decreases. I value decreases, then bulb will glow with less brightness. That is, it decreases the brightness. So option D is the correct answer. Let's move to question number 6. In an AC circuit, an alternating voltage E equal to 200 root 2 sin 100 t. Volt is connected to a capacitor of capacity 1 microfarad. The RMS value of the current in the circuit is dash. IRMS equal to ERMS by XC. IRMS is the root mean square current, ERMS root mean square voltage, XC capacitive reactance. And ERMS is given as 200. That is, E naught is 200 root 2. Okay. Then ERMS is 200 and XC. We want to find XC. What's the formula for XC? XC equal to 1 by omega C. Okay, XC equal to 1 by omega C. And omega is from here. This is E equal to E naught sin omega t. From this omega equal to 100. Therefore, 1 by 100 into capacitance of a capacitor is given 1 microfarad. Microfarad convert into farad, 10 power minus 6. This is equal to 10 power minus 4 comes up 10 power 4. 10 power 4 volts. That is your XC. Then substitute is here by 10 power 4. 10 power 4 comes up 10 power minus 4. That is 200 into 10 power minus 4. Then it gives 20 milliampere. That is 20 into 10 power minus 3 ampere. That is equal to 20 milliampere. That is option C. Option C is the correct answer. Let's move to last question. An AC voltage is applied to a resistance R and an inductor L in series. If R and the inductive reactance are both equal to 3 ohm, the phase difference between the applied voltage and the current in the circuit is dash. That is, XL equal to R equal to only given 3 ohm. Okay, and R also given 3. So 3 by 3. equal to 1. Then phi equal to tan inverse of 1. Tan inverse of 1 is how much? 45 degree. 45 degree convert into radian. Pi by 4. Pi by 4 radian. That is option A. Option A is the correct answer. Thank you, students. In next session, we will see through next session in the next chapter in problem solving session. Thank you.